How angles work and how we measure them. Let's start with the basic question. What is an angle? An angle is formed when two rays start from the same point. That shared starting point is called the vertex. So imagine two paths starting at the same place, but going in different directions. The space between them creates an angle. The amount of opening between those two rays is what we call the angle. So remember, two rays, one shared point, and the opening between them. Angles are measured in degrees. A full circle measures 360 degrees. If you spin all the way around and come back to where you started, you've turned 360 degrees. Half of a circle is 180 degrees, which forms a straight line. And a quarter of a circle is 90 degrees, which forms a perfect corner. So angles tell us how much turning or opening we have. Now let's look at different types of angles based on their size. An acute angle is smaller than 90 degrees. It looks narrow or sharp. A right angle measures exactly 90 degrees. You see right angles everywhere, in corners of rooms, books, doors, and screens. An obtuse angle is larger than 90 degrees but smaller than 180 degrees. It looks wide but not completely straight. A straight angle measures exactly 180 degrees. It forms a straight line. So angles are classified based on how wide they open. Angles also have relationships with each other. Adjacent angles are angles that sit next to each other. They share a common side and the same vertex. When two lines cross, they create opposite angles called vertical angles. These opposite angles are always equal in measure. So if one angle measures 50 degrees, the one directly across from it also measures 50 degrees. We're going to learn an important geometry rule called the Angle Addition Postulate. This rule helps us understand how a large angle can be split into smaller angles, and how those smaller angles combine to form the whole. First, notice point B. This is the vertex, which means it is the common starting point of all the rays. From point B, one ray goes toward point A and another ray goes toward point C. These two rays create a large angle. Now we draw another ray from point B going toward point F. This new ray lies inside the big angle. And when we place this ray inside, it splits the large angle into two smaller angles. So instead of one big angle, we now have two smaller angles that sit next to each other. The big angle formed between rays BA and BC is named angle ABC. When naming angles, the vertex always goes in the middle. So the middle letter B tells us where the angle is located. Now let's name the two smaller angles created by the inside ray. The first smaller angle between rays BA and BF is called angle ABF. The second smaller angle between rays BF and BC is called angle FBC. So the inside ray creates two adjacent angles. Now here's the important rule. The measure of angle ABF plus the measure of angle FBC equals the measure of the big angle ABC. In simple words, the parts add up to the whole. This is exactly what the angle addition postulate tells us. Notice how each part of the equation matches a piece of the diagram. One small angle corresponds to one part of the equation. The other small angle corresponds to the second part. And together, they equal the large angle. So the diagram and the equation are showing the same idea. Let's see a quick example. Suppose the first small angle measures 35 degrees, and the second small angle measures 50 degrees. To find the big angle, we simply add them. 35 plus 50 equals 85 degrees. Let's learn how to solve for a missing angle using the angle addition idea. First, focus on point M. This point is called the vertex because all of the rays start from this location. So everything we're studying today happens around this one point. Next, look at the two outer rays, one going toward point L and the other going toward point T. These two rays form the large angle. And we are told that this entire angle measures 39 degrees. So that is the total amount of angle we are working with. Now another ray appears between those two rays. This new ray goes from point M toward point S. And because this ray lies inside the big angle, It splits the large angle into two smaller angles. So now we have two smaller angles. One of them, angle LMS, is labeled X, which means its measure is unknown. The other smaller angle, angle SMT, is given as 12 degrees. So together, these two smaller angles must equal the big angle. Because the big angle is made of these two smaller angles, we can write an equation. The first small angle plus the second small angle equals the whole angle. So we write x plus 12 equals 39. This equation comes directly from the diagram. Now we solve for x. To isolate x, we subtract 12 from both sides. So we get x equals 39 minus 12. And 39 minus 12 equals 27. So the missing angle measure is 27 degrees. And that gives us the size of the unknown angle. Once you understand this process, solving angle problems becomes much easier. And you'll see this type of reasoning again and again in geometry.